Today we're going to talk about how to apply quadratic equations and where we could use them to solve real-world problems. So we're just going to go ahead and do about 5 problems. The first one, the height and feet of a diver above the water can be modeled by h equals negative 16t squared plus 8t plus 8, where t is time in seconds after the diver jumps off the platform. Find the time it takes for the diver to reach the water. What I want you to consider is his height above the water when he reaches the water is going to be 0. So really, all we need to do is take that equation and put a 0 in for the h. Okay, then when I'm deciding to solve, the first thing I'm always going to look for is a GCF. Notice I can divide all of these by 8, and I'm actually going to divide them all by negative 8. So when I do that, I'm left with 0 equals 2t squared minus 1t minus 1. From here, I can do my discriminant to decide if I can factor or need to use a quadratic formula. When I do that, I get a number that I can take the square root of. So I'm going to tell you you can factor this one. So 2 times negative 1 on the top gives me negative 2. Negative 1 goes on the bottom. So I need two numbers that multiply to give me negative 2 and add up to negative 1. Negative 2 and 1. Since there's this number out front, we have to do AC split. So we have 2t squared minus 2t plus 1t minus 1. We're going to make two groups and factor this. So in my first group, I can take out a 2t, so I'm left with t minus 1. In my second group, I actually can't take anything out, so I'm just going to put a 1 there. My two groups match, so I have t minus 1 in the first parentheses and 2t plus 1 in the second group parentheses. From here, I'm going to take each part and set it equal to 0. So I get t equals 1 for the first one. And t equals negative 1/2 for the second one. Now what I want you to consider is we're actually looking at a real-world problem and we're asking the amount of time it takes. We can eliminate the second option because time isn't going to be negative. So we can't use that one. So it is going to take 1 second. Okay, I'm going to let you try the next one, so we're not going to go through that. We're going to do example 2. So Ms. Prezada is building a retaining wall along one of the long sides of a rectangular garden. The garden is twice as long as it is wide. It also has an area of 578 square feet. We are going to go ahead and draw a diagram here. Okay, so it is twice as long as it is wide. So if I take my width and multiply by 2, that's going to give me my other side. And my area is 578. So to set up my equation, I need to remember how to find area of a rectangle, and that means we're going to do length times width gives us our area. We're going to simplify. We have 2w squared. And then when I'm looking at this, I notice that I can actually solve using square roots because I have a w squared but not a w. So I'm going to divide by 2, which gives me 289. And then I'm going to take the square root of both sides. The square root of 289 is positive or negative 17. However, since I can't have a negative side length, I know that the width has to be positive 17. Now the actual question, though, is what will the length be? So we're going to go ahead and do 2 times 17, which gives us 34 feet. Next one. A house is on a lot that is shaped like a trapezoid. The solid lines show the boundaries, where x represents the width of the front yard. And find the width of the front yard, given that the area is 6,000 square feet, round to the nearest foot. So area of a trapezoid is 1/2 of b1 plus b2 times the height. So we're going to label these b1, b2, and height. So plug those in. So the area is 6,000. I'm going to add those two together, so b1 plus b2, I just wrote those backwards, but it doesn't really affect it, times the height. So let's go ahead and combine like terms and multiply this out. Okay, if you multiply 1/2 times 3 times 2, we actually get 3, and x times x is x squared. So now we get to a point where I can actually solve by square roots because I have an x squared and not an x. And we're going to take the square root of 2,000 to get about, if I round to the nearest foot, 45 feet. So remember, we're going to eliminate the negative one, since we can't have a negative length, so we get 45 feet for an answer. Go ahead and try the next one, and then we will go through example 4. Okay, so example 4 here. We have a rectangular room, has an area of 195 square feet. Its width is 2 feet shorter than its length. Find the dimensions of the room and round to the nearest foot if necessary. So let's go ahead and draw a diagram here. So we have our room. Its width is 2 feet shorter than its length. So its length, and then its width is going to be the length minus 2, and the area is 195. So we're going to go ahead and set this up. Remember, to find the area, we're going to take our length times our width, and I apologize for that. Those of you who are being thrown off, I use cursive L so they don't look like ones. So L times L minus 2 equals 195. We are going to distribute this, so we get L squared minus 2L equals 195. Now, an easy way to do this one, since it's already set up the way we need it to, is to actually complete the square. So I can do this. L squared minus 2L plus something equals 195 plus that same thing. Once we have done that, we're going to take half of negative 2, which gives us negative 1, and then square it, which gives us 1. So we're going to add 1 to both sides. So we can go ahead and factor using nothing.